Okay, so we in the last lecture we stopped at this point of time, right? That means we are going to develop the DFDs for root mean square, calculating software, right? So root mean square is something like this. Okay, so first you will be getting whatever the inputs that you are going to give to the system, so that first it will calculate square of all of the inputs, and then sum up all those things divided by the number of the inputs. Okay, so and then at last you will be getting the square root of those that value, right? So that is what going to give you root mean square. Let's say, for example, you have a, b, c. These are the three inputs you are going to give to the system. So what would be the output? It is the square root of a square plus b square plus c square by 3. Okay, this is what exactly we are going to compute, right? So now the first level diagram, that is a level 0 DFD or context diagram, where first we will have the whole software. The software we are going to develop is is represented by a single bubble. Okay, I mean all of the functionalities will be part of this bubble as of now, you can think of, right? And here you will be identifying the external entities as well as the data items which will be given as an input to the system. Okay, so that is the reason why you have a compute RMS. Okay, and the level is 0, and there is external entity user and the data inputs given by the user, and the user is one who is going to consume the output also. That means he is going to take the result. Okay, that is computed by this particular high level function. Okay, so this is what we call as context diagram, right? Now, as part of this RMS calculating software, you can see there are certain things, whenever you input the number, so that first, it is checked that whether the number is a valid number or not, whether the number that is picked is taken from a range of values -13 to a -1000 to +1000, whether the value is in between this range or not. Okay, so if the value is falls between these two these two extremities, then only you consider that as a valid input, right? And then you will calculate the square of those inputs, and then you will going through a mean square of those input values, and then square root, and then ultimately the result. Okay, now your level level 1 DFD looks like this. Okay, so what you try to do, so the first high level function, whatever you have seen in the context diagram, that is compute RMS, that is exactly maybe decomposed into 4 bubbles, right? So the first bubble is a read number. Okay, that means this is the processing function. Okay, which is going to read the data from from the external entities actually. Okay, so that means this is the method or the processing which involves taking your data, right? Once after reading this number, now this number will be given as input to the other processing function. Okay, now this validate numbers, what it going to do? So it is actually going to check whether a number is a valid or not. Okay, whether a check whether the number is a valid or not, right? If once it is a valid, that valid number will be given to the compute RMS. Okay, now that compute RMS will be the third bubble, right? And after computing this, what you say, root mean square, now this output will be given to the display processing function. Now the display processing function, what it will do, it will display, I mean it will going to give you to the to the external entities, right? The external entities who are going to consume this result, right? And if the number is not a valid one, probably, maybe you sending an error message. Okay, so this is what exactly we try to represent any of data flow diagrams at level 1. Now, so in the level 1, so always you have like this 0.1, 0.23 like this. Okay, now in the level 2, maybe you wanted to decompose certain number of functions, right? Maybe I want to decompose this compute RMS. Okay, I will compute, now there is a compute RMS bubble, so I wanted to decompose this further into sub levels. So in the next level, so the numbering will come like this: 0.3, 0.3.1, 0.3.2, like this, because you are going to decompose this bubble, right? Now we'll see. Okay, so this is what exactly we are doing it. Okay, so now first you calculate squared sum. Okay, so whatever the squared sum you get, now this squared sum value will be given as input to the calculate mean. Okay, mean means here it will be one divided by those many number of inputs. Okay, so the first bubble calculates, it is something like this: a square plus b square plus c square. Okay, and this output is given as input. Now here it will be calculated a square plus b square plus c square by 3. Okay, where whatever the result comes, that will be given as input to the calculate root. Now here square root will be calculated, square root of a square plus b square plus c square by 3. Now after that the output is coming up. So now you can think of this way. Okay, so this is what looks at level 2 DFD. Okay, now so now we can further go into level further into another level, right, where you can see how we can calculate this, maybe 0.0, 0.3, 0.3. So we wanted to decompose this, or maybe you wanted to calculate squared sum, or you may decompose this, right? So we'll see this first one, calculate squared sum. Okay, so we are going to decompose. So in the next level, so usually the bubbles will be given a number with a prefix of 0.3.1, and after that 0.1, 0.2, like this. Okay, 0.3.1.1, 0.3.1.2, like this. Okay, and 4. So here again we have squared sum is decomposed. So what it all taking? So it is taking an input A, B, C, and then it is giving A square, B square, C square, and that is what given to another processing function, right, or a bubble. So now this bubble is actually carry out the summation of all these squares. Now this is what exactly a squared sum. Okay, now we can think of this way. Right, so decomposition is never carried on up to basic instruction level, right? So that means you will be going up to a level where so something can be represented by a simple set of instructions. Okay, so because once if you arrive to a bubble where you can implement that using a simple algorithm, or you can think of a simple set of instructions, so there is no point of again further dividing that bubble into sub bubbles, which will again further increase the complexity otherwise. Okay, so you'll be going up to a level where you can define, I know you can you can represent that particular bubble by a simple set of instructions. Now, so this is all about DFDs, right? So now along with which, So there is something called a data dictionary. Okay, so DFDs, what you have part of this, what you have seen. So you have seen decomposition of functions, right? So this is the functional aspect of the system you have seen. Okay. Now, along with DFDs, so usually, a data dictionary also accompanied. Okay, so a data dictionary lists all data items appearing in a DFD. So usually, so whatever the data items that are, that actually, appearing in a DFD will be provided in the form of a data dictionary. Okay, so definition of all composite data items in terms of their component data items. So we'll see how we are going to define these all composite data items. Okay, along with some data names, along with some purpose of data items also we'll see. Let's say, for example, one entry of any data dictionary can be like this. So let's say you have a gross pay. Okay, if it is a payroll sort of software you are going to develop, then one data item may be gross pay. Okay, now this gross pay is actually, it's a composite data. Okay, now you can say, so you have regular pay. I mean, there is a regular pay defined, along with which overtime pay. Let's say someone is do some overtime. Okay, so someone works then the regular time. So I mean, he works uh, apart from 8 hours of working hours, so he may go for another 2 hours or 3 hours or something like that. So sometimes he earns overtime pay also, right? So now your regular pay plus overtime pay will be a gross pay, you can think of. So now this can be one composite data, right? So now these sort of data, whatever that appear on the in a particular DFD will be listed in the form of data dictionary. Okay, now so it all provides all engineers in a project with standard terminology for all data. A consistent vocabulary for data is very important. Okay, I mean, so you should be, the names you should be giving in such a way that, the user or the customer can easily understand, right? So different engineers tend to use different terms to refer to same data. So that should be avoided. So otherwise it leads to confusion, right? So always you try to give consistent name to the kind of data. I mean data, whatever the data you are going to use, right? So you need to you need to apply some consistent vocabulary, right? So for the same data item, we should not, give two names. Then it will really leads to confusion, right? So, so in your data dictionary, you are exactly as part of data dictionary, you will see various definition of these different data items. Okay, so for a very large systems, so usually your data, because for a large system, what will happen, you will have more number of functions or the bubbles or the processing. When you have more number of functions or processings or bubbles, so usually along with which the data items that will be flowing between them will also grow, right? That is why we said that the data dictionary will also grow in size and complexity. So typical projects can have thousands of data dictionary entries, right? So now you can understand, now you will have so many of data items, okay, entries. So it is extremely difficult to maintain such a dictionary manually. So you cannot manually maintain all of this data dictionary. Sometimes you can use some automated this data dictionary. So there are case tools which can capture your data items appearing in a DFT automatically to generate the data dictionary. So there are case tools available. Okay, so through which you can, if you say that there is a data dictionary, you have a DFD, so automatically it is going to pick out all the data items from the data DFD. Okay. So right. So and then so these whatever the case tools that you are going to use. So sometimes they also supports some sort of queries, like whenever you wanted to know where this item, how this item, data item will be used and what its definition, you can ask a query, so then you will be able to know. Okay, queries may be made to find which data item affects which process. Okay, so at any point of, because I told you there are thousands of data items, right? And these thousands of data items, they are taken from the DFD, right? So at any point of time, so the customer or the developer wants to know that these are the, let's say there are 4 data items you picked and you wanted to know. So these data items, actually related to which particular process, okay, or the function or the bubble, okay. So that is what you can able to get. Okay, let's say these are the data items actually will have an effect on, these are the different. If you make any changes to these data items, so maybe you can think of, okay, what are the different processings that will get affected. Okay, so these sort of things can be you know these sort of things can be queried, and then you can get the replies, right, from these tools, right? So these tools, actually case tools, they can support. So query handling is facilitated if data dictionary is stored in a relational database management. So you can see, right, sometimes these the data dictionary can also be stored in the form of RDBMS. Then you can have a SQL queries that you can put, you can submit the SQL queries so as to get the appropriate answers, right? So now the as I told you, so you are going to define the data, right? So your data dictionary will provide ways to define the data items, right? So now we will see. So if you have a certain number of composite data items, let's say if you have a composite data, and that composite data is actually defined using certain maybe using some primitive data items. Let's say you have, for example, you have a composite data item. Here is something. Maybe it's a combination of data item A and B. These are the 2 primitive data items. When you combine these 2, so it is going to give you maybe the C data item. Okay, so how can you represent that? So composition of data items can be represented by plus. Okay, so that is the reason why the previous slides, so I gave you an example of a gross pay. So gross pay is the, so basic pay plus the overtime pay. That means here the plus operator exactly going to represent that. So this data item is a composite data item. Gross pay is a composite data item, right? It's a combination of 2 data items, right? So that can be represented through plus. And now there are something like selection also, so appears usually, you know so let's say, for example, you can have something like this. Okay, so some data item can be of this form. Okay, so it is a composition of A and B, but sometimes A occur, sometimes B occur. Okay, if that sort of things are there, then that can be represented by the square bracket, and within which you will be writing all the data items separated by a comma. Okay, so that means if somebody writes a comma B within the square bracket, that means sometimes A can appear or sometimes B will appear. So uh, this can be represented through this way, right? Now if you write something, some contents inside this bracket, so that actually represent optional data. Okay, so let's say this is what I can say. So maybe you have a data item like this. Okay, A plus B, and within the B is within the bracket, right? If it is there, then in that case, so what are the possible data items, the composite data item that can be of? So either it can be A, because B is the optional one, or if B appears, then in that case it will be a plus B. So these are the so this is a way that you can represent your composite data, right? So something, whenever you wanted to say give some instances, iterative sort of things, right? So in that case, where you can have data item within the curly bracket, okay, and outside the number of times that you going to iterate the data definition, that can be that can be written by a giving number. So example, you can see, so name within the curly bracket and outside 5, so that represents 5 name data, okay. So five name data it is going to take, okay. That means that same definition will be applied for the 5 times, okay. Now somebody write like this, name and star, which can which can represent. So instead of number, you can have a star also. When you say star, or more instances of the name data, okay. So that's a other way to say whenever you wanted to say 0 or more instances of some data, okay, name data. So this is a way that you can represent instances, right? And sometimes your equal represents equivalence, right? A is equal to B plus C. If somebody says so, so A represents B and C, okay. So that means gross pay is equal to, we have written, right? So basic salary plus overtime salary. So that means gross pay is equivalent to B plus C. So either A or you say B plus C, they are equivalent, right? So this way you can represent, right? You understand. And something that you write within, star and star. So that is actually considered as a comment. Okay, that is considered as a comment. Now, so for your RMS software, I can create a data dictionary like this. Okay. So now the first, the one, so you are going to give a number, right? So maybe the valid number is, okay. So the valid number can be A plus B plus C. Okay. Now you can say like this, okay. So any number can be, you can say A plus B plus C. Maybe it is a composite number, right? So for this, A can be defined like this: A colon integer. That means it is a integer value. It is going to take the input A. So and within star, whatever you are writing, that is actually going to tell you that it's a comment. So if you wanted to give any comment at any point of time, so you can give comments within these two stars, okay. And B integer, so it is another input. C is another input, right? If I write ASQ, maybe the data item I am going to use, right? So that is going to represent A square. Okay, see, this will also be integer. Another data item I am going to use, that is a B square. Okay, so BSQ. So that means it is also integer. CSQ, right? And then squared sum is another integer, because you found like this: A square plus B square plus C square. Okay, that is going to give you squared sum. This is another data item, right? Now, and the result can be like this. There are two things, because I told you. So either the result will be error or it will be a root mean square. If the number is not valid, in that case, it is going to give you error. Okay. So that means there is a selection. Okay, there is a selection appears, right? So result, yeah, so data, so that there it involves some sort of selection, right? So now RMS is also an integer, so which will represent root mean square value, and error is just string. Okay. So now this way, so you can here I have not given the other ones, like star things, okay. Because here it is not required, okay, and optional things. So you can have all those things also, right? So if you are going to have any software for which if I ask you to give the data dictionary, so you will be whatever the data items that will be appear that are appearing or that appear in a DFD, so they will be represented using data dictionary. Okay. So we have seen there is a DFD. Okay, now there is one of the important aspect of DFD is that you need to always balance this DFD. Okay, so that means what it all says is what it here. So as I told you, as part of this DFD, so data actually flowing into a bubble and the data will be going out from a bubble, right? So usually that is what happening, right? Now what we are doing here is, so let's say in the next level we are decomposing that particular bubble into sub bubbles, right? We are decomposing a particular bubble into sub bubbles, but now you can see, but for that particular, before decomposing, that bubble takes certain number of inputs, right? And it is giving certain number of outputs, right? Now even if you that particular bubble into sub bubbles, you need to see that whether the inputs that was given, okay, in my that was given to the bubbles as well as the output going out from the bubbles, even after decomposition, still that should be the same. Okay, I mean in the let's say you have a bubble at level 0, right? Now that bubble takes how many inputs? Let's say 2 inputs, okay, and gives output 2. Okay, now that in the level in the level 0, so this is what, okay, you have 2 inputs and 2 output going from the bubble, right? Now in the level 1, that bubble is decomposed into 4 bubbles. Even if you decompose that bubble into 4 bubbles, but you need to see that actually the input going into this decomposed bubbles, okay, so that should be should be the 2, and that going out from that particular decomposition, overall out from that particular decomposition, right, should be again 2. Okay, that is what we say balancing a DFD. Okay, so we'll see that with an example. Maybe if you do not understand at this point of time, you can understand in the list. Okay. So this is what exactly we try to do. Okay, let's say in a level 1, okay, in a level 1, let's say, so you have, these are the 3 processings. Okay, these are the 3 processings. Okay, so processing P1 takes A input, processing P2 may take input B. Okay, that means how many inputs to a processing 1? So you see that there are 2 inputs, okay, D and A. Okay, that's the 2 inputs going to P1. And how many input going to P2? There is only one, B. Okay, and how many output going from P2? 1, C. Okay, now similarly for P3, how many input coming here? Only one input. Okay, and how many output going here? How many outputs?
2.
2. Now outputs are 2, so E and D. So that means, so at this point of time, this processing P3 has only one input and 2 output, right? Now in the next level we are going to decompose this P3 into functions, right? So what are those sub functions? So that will be 3.1, 3.2, 3.3. Now if you see, so this P 3.1 takes one input, okay, and takes one input as well as it takes another input as a D1 from P3 2.1, right? And it is going to give you some output C1. Okay, whatever may be. So for each and every processing, you might have different number of inputs and all, right? But what you need to see here is the overall, how many inputs, okay, how many inputs that is coming from the level 1, okay, and how many outputs going from this level to other levels, so that should be 2 and 1, okay. Do you understand? So that means, so if you see here, let's say for P.3.1, there may be 4 inputs, 5 inputs, any inputs according to your decomposition, right? Similarly, for P3.3, also you can have any number of inputs and outputs, right? So P3.2 also can have any number of inputs and outputs. So now what you need to see is, now that decomposition is fine, okay, inside that you have decomposed those functions and you have given, you have designed some in such a way that so they can have different number of inputs and outputs, but overall what you need to see is, so so for P3, how many inputs were there in the level 1? So 1. How many output were going out from that P3? So there were 2, right? Now when you going to level 2 also, you need to ensure that one of the input should be coming from level 1 sort of thing, right? That means only one important input is given to the P3.1, okay. Now after that taking input, so it may be carrying out certain processings within that, but P3.3 is giving one output and P3.2 is giving the other output, okay. So E and D, so that is what you need to, okay. So that means, so whatever the number of inputs and outputs uh, that were there in the previous level for a processing or a bubble, so that same number of things should be maintained at the next level also. You may have, within the system, I mean within the bubble, you may have as many number of the inputs and outputs for each and every sub functions, but ultimately you need to ensure that, so those many number of input and output should be maintained even in the next level also overall. So that is what exactly I represented. So C is given as an input to this particular level 2 decomposition, and one output may be going from 3.2, one output going out from 3.3. Is it clear or any doubt? Anyone? Any student here who do not understand this? That means it is clear to all of you, right?
Yes, sir.
Okay. So right. So the numbering of the bubbles that you understood, okay. So your context level start with 0 and your level 1 start with 0.1, 0.2 sort of thing. And the next levels may be 0.1, 0.1, 0.1, 0.2 this way. So that way you will be decomposing and giving the numbers, right? So now you can think of any um, so a TikTok toy game also 3 by 3 square if you have, okay. So you can have certain number of inputs, maybe the input number between 1 and 9 to mark a particular square. Uh, so there will be a game between two, right? So you will have to place in such a way that 3 consecutive marks along a straight line or along a row or along a column. So you understand, right? TikTok game, TikTok toy game. So he is one who is going to win the match, right? So alternatively, you will be giving moves, right? So whoever wins that particular game, so that message will be displayed, okay. So if neither of the two players, they manages to get 3 consecutive marks, so then in that case, all the squares on the board are filled up, then game is drawn. Okay, so that means, so that game is considered as a draw. Okay, so that is what exactly the game TikTok toy game. So for which You can have a context free diagram like this, right? Human player who is going to give the moves, right? So and then so the external human player who is going to see the result also, right, of this game. So this is a context free diagram, sorry, context diagram, right? Now for this you can have always a level 1 DFD also, right? So so in the level 1 diagram you can have something like this. First you need to see validate the move, okay, then you can display the board, right? So and then check the winner, okay, so or play a move. So you can manage this way, okay. So you can have so many numbers, so for which also you can have some sort of data dictionary, like now. So we have seen structured analysis and structured design. Hmm. So we try to we have seen two different important parts of this thing is structured analysis and structured design. Hmm. And so we have seen that basically the structural analysis is being carried out to decompose the functions, I mean to decompose the system into smaller functions, right? So whatever the results that you getting from a structured analysis, that will be represented using a data flow diagrams, okay. So you have seen that the data flow diagram uh, have the actually uses a hierarchical model. That is what you have seen, right? So you have seen some sort of decomposition at different levels, right? Hmm. So as part of structured design, so we will see something, this DFD, whatever you have seen as part of structured analysis, okay, so that will be converted into a structure chart, okay. And now so DFDs are very popular because of the very elegant and simple technique it is, okay. So the customer or the users, they can easily understand, okay, because it all uses very consistent vocabulary, right? So they try to avoid all computer jargons, right? As a result, it is very simple and it is very elegant and it is useful also, right? So a DFD model difficult to implement using programming language. So usually DFDs are the graphical representations. So you cannot from directly DFD you cannot directly go and code some sort of programming, right? So that is not possible. Structure chart representation can be easily implemented using a programming language, right? So now once this DFD is converted into the structure chart, then that can be actually easily implemented using a programming language. So that is what we have studied at the very beginning, when we were talking about the software design, right? So where you going to see all different module structure, right? So we have discussed two examples, RMS and tic-tac-toe, right? We have gone through structured analysis, right? We have represented that DFD, and also we have seen the data dictionary, how you can generate the data dictionary out from this DFD, right? And also there is important concept of balancing of the DFCs are also discussed, right? Fine. Any doubts so far, students?
No, sir.
So everything is fine. Okay. So can I switch into the other part?
Yes, sir.
Yes.
Okay. So so far we have seen structured analysis, right? Now we will be going into how we can convert this, DFDs into structure chart. Maybe in the slide I'm going to upload. So we'll discuss about those things, right? And also we'll little bit discuss about the drawbacks of these DFDs and all. Okay.
The exam.
No. It will not be there. I told you. So till only the function-oriented design, neither object-oriented design. Okay, those things will not be there. I told you. Only till software design. Okay. So I have uploaded all the slides as well as the videos. Okay. Now you can prepare everything till that. Okay. So let me upload the other slide. Okay. So now we'll see. Can you see the new slide, students?
Yes, sir.
Yes, sir.
Okay.
Yes, sir. Yes.
Okay.
Yes.
So now we'll see certain guidelines while you constructing. You need to follow them. So while you constructing the DFDs, right? And then we'll see how we're going to transform these DFDs into structure chart. Probably we have already discussed about structure chart while we are discussing about we are having discussions on software design phase during the life cycle model discussion, right? So still I will be again going to repeat this a little more, right? So now we'll see first certain guidelines. So right, so as part of your context diagram, you always going to see only a single bubble, right? And where you see all external entities, okay? So, but these external entities should not, should not appear at any other level of DFD except this context diagram, right? And also you see that each and every bubble should be divided into 3 to 7, right? So that is what the guidelines. So the other guideline here is attempting to represent control information in a DFD. So always we try to represent the control information in a DFD. Actually, uh, I mean, DFDs actually doesn't represent control informations, right? That means in what order these functions are getting invoked or executed, right? So that is not defined here. Okay. So what, and also under what conditions these functions are invoked, right? So these things are also not part of any DFD. So this is actually, I mean, we should not provide, we should not give this sort of information in a DFD. Okay, so that is not going to represent. Okay, so your DFD is not going to represent that. But so that means in which order these functions are getting executed, or in which order these the input data items that will be given. So those things are not represented at this point of time in DFDs. Okay, as part of DFDs, that is not. Okay, so let's say if you wanted to have this sort of thing, so check the input value, right? So right? So checking the input value. So I said you, so sometimes you see, so whether the number that you have entered, okay, whether it is a valid or not. If it is valid, then only you do these things. So if it is not valid, then you doing that thing, okay? So these sort of things actually we are not representing in the DFD. Okay, as part of DFD, we are not doing that. Okay, so usually, so this is not going to represent all these things, right? So mostly what it all represent is the high level functions, okay, processings. Okay, so because you see here in this diagram, you can see you cannot give any data or you cannot annotate any data with any level here. Okay, what sort of data you are going to annotate with this? So I mean, I have not given any, when you give any number, right? So when you give any number to this check number function or the processing, so if that is a valid number, then that number is given as input to the search function. Okay. If it is not valid, then you cannot say simply showing a error, showing that it generate an error message. So you cannot say, because you need to give some data item here. Okay. So that data item is missing here, right? So I mean, so those things will not be you know so represented in any DFD. Okay, that means here you are going to give some sort of control information, right? Means if this number is not valid, maybe you are going to give some error message and all. So usually those things will be avoided in DFDs. Okay. So all functions of the system must be captured in the DFD. So that means whatever the functions that are mentioned in the SRS, so everything should be their part of DFDs. Okay, so no function should be overlooked. That is what we say. Okay, only those functions specified in the SRS document should be represented. Okay, so you do not assume certain extra other functionalities. Okay, which are which are not specified in the SRS document. So those functions which are there part of SRS, and then you try to provide a bubble for that particular function. Okay. So certainly, commonly these are the errors that we make mostly. So we do not balance the DFDs, right? So we forgetting to mention the names of the data flows, like the previous diagram I have shown you, right here. So the data is not given, right? So check number, after this one section it is going to give you number, the other one is other branch is the other data flow, but there is a no data. Okay, that means so we shouldn't have like this. Okay. So unrepresented functions are data. So we do not represent some of these data or functions in the DFD. We completely omit them. So external entities, they are appearing at the level 1 and level 2 diagram, so that should not appear, right? So trying to represent control aspects, right, as I told you. So when you have some sort of conditions, if this happens, then you execute this processing, then only you execute that particular processing. So these sort of things are not there, right? Control information will not be represented, okay, as part of DFD. So you cannot have that particular aspect, right? So context diagram having more than one bubble, okay, so that is also it's a mistake, right? I told you. So always it will, the context diagram will have only single bubble, right? So which will be representing the whole system, right? So a bubble decomposed into too many bubbles in the next level, that is also not allowed. So as I told you, 3 to 7 number of bubbles, right? Terminating decomposition too early. I mean, sometimes, so I mean, you need to go to certain number of levels. So we try to terminate them as early as possible. So that is also not good. Okay, as a result, still we might not have obtain the appropriate level of abstraction, right? So nouns used in naming bubbles. So sometimes I told you these bubbles are the actually processing functions. So they are actually the verbs. Okay. So we try to give nouns instead of that. So these are the common errors that we make while we designing this DFDs, right? Now, there are some shortcomings of these DFDs. That means so you can see certain things the DFDs are not going to represent, right? So because so it also leave scope. It also gives scope to be very imprecise. Why? Because I told you, so each and every bubble will be given a label, okay, but maybe whatever the level that you give to a bubble may not going to address or capture all of the functionality of that particular bubble, right? So I say let's say if I say sets, okay, if I gave a bubble name sets, right? Now part of searching, there can be many things, okay, right? So there can be many other functionalities, right? Let's say, for example, if you're giving any incorrect input to the search function, okay, so what will happen? If some of the data inputs missing, so then in that case, how your search function is going to act, okay? So all of these functionalities maybe may not capture all of these things, right? As part of when you level a particular bubble, so sometimes it still leaves this sort of imprecision, okay? So that is the reason why so it is to be imprecise sometimes, okay? So that's a very example here. So find book position. So I mean by seeing this bubble name, okay, find book position. So you may understand that way that particular book is available, okay, but in the library or something like that, right? But certainly along with which there are many other reasons, right? So what happens when some input information is missing or incorrect? Does not convey anything regarding what happens when the book is not found, okay? If the book is not found, so in that case also it is not conveying that sort of message through this level, right? From this level what we understand is only very precise something we are understand, right? So this is the bubble actually going to handle in a when you give input to the function, so it is going to tell you where that particular book is. This much only it is telling, right? So there are certain other things also associated with this function, but it is not going to tell because we are giving a label to this function, okay? What happens if there are books by different authors with the same book title? So these sort of, there are many scenarios part of each and every use case. So, and those scenarios we have not taken into, when you give a level, so that will not be implicitly, they are not coming, okay? They are, so we should, we cannot define implicitly all of them or explicitly all of them, right? So that is quite difficult again, right? And the control information is not represented. That means, you see, for this particular processing, so there are so many input data coming, right? So one customer history, one customer file, one order, and one file, and one inventory file, one inventory data is coming now for to this accept order. So there are so many data items, but can this diagram is representing this? Which one should be, which one data input will be considered first? Is it mentioned? No, it is not mentioned. So this sort of things, right? So the control information is not represented. I mean, which input data should be given first, or which one will be given last, or which one, so there is no order of, inputting of these things are mentioned here. Only thing is that this is the processing function going to take, these are the different input data. That is what it is giving. That means the control information is not represented, okay? And the DFDs also not specify the synchronization aspects, okay? now in the previous example, if you see, it is a trade house system for which the DFDs are, right, where you so certain orders are placed and those order will be processed, and then thereafter something like this, okay, and the order will be delivered to you, okay. So this way something like this, okay, that the system for which, right. Now what we are trying to say here is, so I mean it is not going to specify any synchronization. That means unless or until one processing will be done, okay, so the other processing, whether that other processing has to wait or not, so these sort of things actually are not represented, okay, whether that particular whether some sort of buffering sort of schemes whether will be there to address or not, those sort of things are not there, okay. I mean you can say like this. So whenever there are orders coming, right, even if you cannot handle at this point of time, so you may accept those orders and you can store those orders, right, and later on you can handle one by one, okay. This way you cannot or whether they are going to execute simultaneously, okay, these processings, whether they can be processed simultaneously or not, these sort of things actually are not represented, okay. So that is the reason why so it is not addressing the synchronization aspect, okay. So synchronization aspect is something like this, okay. So one processing is executed and after that the other one will be processed, okay, right. So these sort of things actually we do not maintain, as I told you. So we do not have the control informations also, right, and the order in which this processing or the functions will be carried out, so this is also not mentioned, right. So right, so here it is not which processing should execute fast, and whether these processings will be carried parallelly, okay, whether they can be executed parallelly. So those sort of things are not mentioned. I mean is not actually representing through, we cannot represent those things through these diagrams, right. So then the way decomposition is carried out to arrive at the successfully level of DFT is subjective. So here also it is all depends upon the analyst. So I mean which function he wants to decompose, which function he doesn't want to decompose. So everything is with the analyst, okay. He will decide, okay, and so as a result you see, so there is always a scope for different alternative DFDs, okay, representations, maybe for the same sort of problem, okay. So maybe you are going to get, if there are depends upon that analyst, okay. So the DFD may be, so the representation may be different, okay. Different DFDs may come out as a result, okay, of two different analysts, okay. So let's say there is a project A. If the project A is given to a analyst A, okay, so he may be going to give you one DFD representation. If the same DFD in the same problem is given to another analyst, maybe he is going to give you another DFD, right. So this is the way that you need to understand, because so it is a subjective, okay. So this decomposition is a subjective matter. So that is one disadvantages. The other one is, so there is no mechanism or ways to tell you that how exactly one should decompose these functions, okay. So there is no mechanism as of now, so that is also one of the disadvantages, right. So where you need to stop this decomposition, right, that is also not known. I mean way to stop this decomposition, whether at what level you need to stop the decomposition process, right? So this is also not this is also not going to specify, okay, your structured analysis techniques. Now the other thing is structured design. So we'll talk about this in the next lecture, okay? So we'll see there how to convert this DFDs into the structure chart and all in the next lecture. We'll see about this. Okay. So any doubts so far, students?
No, sir.
Okay. So I okay. I downloaded the attendance sheet. Just give me a minute. Okay.
Sir, what about the syllabus of test?